Greetings, fellow mathematicians. We're going to take a quick look at the alternating series test and how to apply it. So first, the term alternating here refers to the fact that the terms in our infinite series here are going to strictly alternate from one term to the next. In other words, we have a positive followed by a negative, positive followed by a negative, forever. Now the first term could be negative, but then it would have to be followed by a positive, then a negative, then a positive. Just make sure it is strictly alternating. Now, there are some statements here for the conditions of the alternating series test, but before we go any further, there is one particular part for the term of this infinite series that we're going to need to pay attention to. So there's two terms here. There's the -1 to the n-1 or -1 to the nth power. That's what I'm going to call the alternating term. It's going to alternate back and forth between positive and -1. But to check the conditions for the alternating series test, we're going to look at the other part of the general term, which is denoted b sub n. And b sub n in this expression, that's just going to give you positive numbers. The alternating term will give you the alternating signs. So let's take a look at a quick example to identify what b sub n is. So typically when you're given an infinite series, like this example here, just get in the habit of rewriting it. So if I take my term here, I can bring that alternating term, -1 to the n-1, I can bring that out front, and I can rewrite that like this, and that will look more like the general statement here for the term in an alternating series. We have our alternating term, but more importantly, this part right here, that would be what we're going to call b sub n for the alternating series test. So for that example, b sub n would be 1 divided by 2n plus 1. So before you go ahead and apply this to any problems, just make sure you're comfortable with that, properly identifying b sub n. Now, once you have identified b sub n, the non-alternating part, that's where all the conditions apply for the alternating series test. And there's two simple conditions for b sub n. First, b sub n is decreasing. In other words, as the values of n get higher, the terms are going to get smaller. The other condition is the limit of b sub n as n approaches infinity is 0. All right, now if both those conditions are met, the alternating series test is very nice. Two simple conditions lead you to the conclusion the alternating series would be convergent. All right, now where most of the work is going to lie, and where you'll have to provide some justification to your professors, myself included would look for this, you can't just simply state that b sub n is decreasing. You might actually have to verify that. So let's take a look at how we can check that decreasing condition. And there's going to be two primary ways that you can do this. If we refer to our previous example, we're typically going to be encountering lots of fractions for terms of infinite series. So usually the simplest way, referencing let's say this example for b sub n, one way a term can be decreasing is if the denominator gets bigger, the whole fraction is going to get smaller. So if we take a look at a different b sub n, you can see here as the value of n gets bigger, your denominator gets bigger. 1 over a big number should get small. So as the value of n goes, that just keeps getting smaller and smaller, approaching 0. Now, that's really simple because the numerator is just 1 and the denominator contains n, which is increasing. Now, there's going to be some examples that have expressions in terms of n in both the numerator and denominator. And if that's the case, you'll probably want to show that this term, or something like it, b sub n, show that it's decreasing by showing that its derivative is negative. And that's where some work and justification is needed. If we identify b sub n as being some function of n, just go ahead and show that that function's first derivative is negative for certain values of n and onwards. All right, and the alternating series test, again, is very simple. Two simple conditions. B sub n, the non-alternating term here, show that it is decreasing and that the limit as n approaches infinity is 0. Both those conditions are met, then the alternating series is convergent. All right, we're ready to get to some examples, but I have those linked below in the follow-up videos. If you enjoyed this short video, support the channel, hit that subscribe button.